Okay, so question number one on your learning guide says state the domain and range for the inverse trig functions and explain why the domains of the original functions need to be restricted in order for the inverses to exist. Well, first off, they need to be restricted so that we will have inverse functions that are actually functions, which means if you think about the horizontal line test, if you run a horizontal line through your function, it can only intersect in one spot. If it intersects in more than one spot, then the inverse will not be a function. So look at sine of x fails that test, cosine of x fails that test, and tangent, if we repeated it, would also fail that test. And so we need to restrict the functions, so let's look at each one individually. So first one, y equals sine of x. Look at this function. How do we want to restrict the domain? Well, we need to choose our domain so that we hit every single y value once, we don't repeat any y values, and we are continuous. The most natural way to split that up is to look between negative pi over 2 and positive pi over 2 right there. Because now notice anywhere you put a horizontal line between those, you will intersect in one point. So clearly I am being foolish. I drew that in the wrong spot. Negative pi over 2 to positive pi over 2 right there, where the function goes from its minimum value to its maximum value. So if we look at sine of x on this restricted domain, looking between the pink lines right there, we will have a domain of negative pi over 2 to positive pi over 2 for sine of x. We will have a range that goes from the minimum value of sine, which is negative 1, to the maximum value of sine, which is positive 1. Both of those are brackets. Now, since sine is the inverse, remember the big idea with inverse functions is that x and y switch. So x, like our domain, and y, like our range, switch. Hence, now the domain of the inverse function is negative 1 to positive 1, and the range is what we restricted the domain of sine to be. So negative pi over 2 to positive pi over 2, just like that. The domain and the range switch, and there you have the values for sine inverse of x. Let's now look at cosine inverse. We'll do the same thing. Cosine, we are going to split up most naturally from 0 to pi. There the function goes from its maximum value of 1 to its minimum value of 0. So the domain here now has been restricted to be 0 to pi. The range is going from its maximum value to its minimum value, so again, negative 1 to 1. And now this will all be flipped for the inverse cosine function. So now the range will be negative 1 to positive 1, just like sine inverse of x. And the range will be 0 to pi, so that is different than sine inverse of x. So if you think of the unit circle, the inverse cosine function will tell you values between 0 and pi, or 180, if you want to think about this in terms of degrees. But it will be using the first two quadrants, whereas sine inverse will be using the first and the fourth quadrant only. So a little bit of differences there. And let's look at the third one, tan inverse of x. Well, I only drew one right there. I could continue drawing more of these forever, because remember that's what the tangent graph looks like. But this domain has been naturally restricted between the asymptotes. So the domain here is negative pi over 2 to positive pi over 2, brackets not including those asymptotes because tangent is undefined there. And then the range will actually be all real numbers, or if you prefer, negative infinity to positive infinity, because those the graph is shooting off towards those asymptotes, towards positive infinity when it approaches pi over 2, and negative infinity as it approaches negative pi over 2. So then for the tan inverse function, my domain now is all real numbers, and my range is values between negative pi over 2 and positive pi over 2. So it's very similar to the sine graph in that it's going to be using the first and the fourth quadrant, but this time we do not include those pi over 2 values. So we've got tangent, we've got cosine, and we've got sine inverses of all of those.